All right, let's dive right in. We've all seen the massive hype lately, right? Those sensational headlines claiming artificial intelligence is essentially out there doing PhD-level math. But what is actually happening behind the curtain? Today, in this explainer, we're popping the hood on Google DeepMind's Aletheia agent. We are going to sift through the noise, figure out what's real, what's just science fiction, and see exactly how a machine is collaborating with human mathematicians to push the boundaries of research.
So here is our roadmap for today. We're going to contrast contest math with real-world research, break down Aletheia's actual mechanics, objectively grade its milestones, define some AI autonomy levels, and then end with a really vital reality check. Section 1. From contests to research. First up, we really need to establish the massive chasm between winning a high school math competition and discovering genuinely new mathematics. This difference perfectly illustrates why large language models struggle so much when they transition from contests to the lab. You know, AI models recently hit gold medal standards at the International Math Olympiad, which is amazing, but contest math is a bounded environment. The answers are already known and the proofs rely on standard theorems. Research math? That's a totally different beast. It's open-ended, it spans dozens of pages, and it requires synthesizing decades of dense, specialized literature. When you force standard foundational models into that open-ended space, they often just completely hallucinate because they simply don't have the specialized training data.
Moving on to Section 2, how Aletheia actually works. So, what specific engineering solution did Google DeepMind build to overcome this exact barrier? Answer: Aletheia. The really cool thing here is that Aletheia isn't some mystical black box magic. It's actually a highly mechanical, iterative loop built directly on top of Gemini DeepThink. And it operates entirely in natural language, which is a big deal compared to previous systems that required super strict formal code.
Think of it as this intense internal debate. You've got a generator that throws out a candidate solution, then a verifier ruthlessly scrutinizes it for flaws, and finally a reviser tweaks it. By decoupling the final output from the intermediate thinking steps, DeepMind is essentially forcing the AI to double-check its own work. Instead of the AI just blindly guessing or letting a long, rambling train of thought convince it of a wrong answer, this dedicated verifier acts as a really powerful quality control checkpoint.
And this leads us to a massive aha moment about computing power. Simply put, giving the AI more time to think during the inference stage directly correlates to its solving much harder problems. Aletheia leverages this by dynamically scaling its compute. So, the harder the problem gets, the more cycles it runs through that generator-verifier loop until it finds a solution.
But wait a second, raw computation alone isn't enough for research. What happens if you ask a totally isolated AI to cite advanced, highly specialized academic papers? Well, it confidently invents fake ones. Seriously, it will hallucinate an entire proof, citing a completely fabricated paper about a pretzel knot. It'll even make up a fake journal issue and page numbers. Because real research requires, reality, equipping Aletheia with tools like Google search and web browsing was absolutely vital to ground its reasoning. All right, Section 3, AI's real math milestones. Now that we know how it ticks, let's look at the actual trophies Aletheia has brought back from the unknown when partnered up with human mathematicians. So here are the concrete wins. First, Aletheia calculated complex structure constants, they're called eigenweights, with zero human intervention. That is a major milestone for AI reliability. Second, on the Erdos problems, which are these decades-old unsolved math puzzles, it autonomously resolved 4 of them. And finally, it achieved leading performance on first proof, which is a rigorous new benchmark created by mathematicians specifically to put AI to the test. But honestly, the most fascinating part is how this completely flips the usual script. There was this collaboration on a paper regarding independence polynomials, which relates to interacting particles in physics. Normally, right, a human gives the big picture vision and uses the AI for the tedious execution stuff. Here, Aletheia provided the high-level, visionary roadmap and the clever strategic ideas, while the human mathematicians were the ones doing the rigorous, line-by-line proof execution. Talk about a role reversal.
Which brings us to Section 4, rating AI autonomy levels. With all these wild headlines screaming that AI is replacing scientists overnight, DeepMind is actually proposing a taxonomy to help us categorize these milestones accurately. To combat the misinformation, they suggest using standardized human-AI interaction cards. These would transparently document exactly how much of a mathematical breakthrough was driven by the AI and how much was pure human elbow grease.
You can think of this a lot like the levels of autonomy for self-driving cars. It scales from level 0, where the AI's contribution is barely novel, up to level 2, which is solid, publishable research. And then it stretches all the way to level 4, which would represent an industry-shattering landmark breakthrough.
So the crucial takeaway here is this. While Aletheia generating a completely autonomous paper on eigenweights is a massive, historic leap for computer science, the math itself maxes out at level 2. It's categorized as minor or just standard publishable research. The AI is not, I repeat, is not producing level 3 or level 4 groundbreaking mathematical revolutions. At least, not yet.
Which brings us to Section 5, AI limitations and reality. Because, the hype train loves to ignore the failures, but we absolutely have to look at them.
When DeepMind tested Aletheia on 200 unsolved Erdos problems, the harsh truth really came out. Almost 69% of the AI's proposed solutions were fundamentally flawed. Another 25% were technically correct, but completely missed the actual intent of the question, meaning a measly 6.5%, literally just 13 solutions out of 200, were meaningfully correct. That highlights a severe level of unreliability that practicing researchers still have to deal with every day.
Plus, even with web search enabled to stop those fake citations, the AI still stumbles. It might cite a real 1976 paper by Galambos, right? But the problem is, the classical result it quotes from it doesn't actually exist in that paper. The AI is basically squeezing and twisting legitimate math to conveniently fit the narrative of its own proof.
So, zooming out, what are the overarching limitations right now? Well, AI currently lacks genuine mathematical creativity. Its successes mostly come from vast data retrieval or clever mechanical manipulations. It is also highly prone to specification gaming. That means if there's any ambiguity at all in a prompt, the AI will take the path of absolute least resistance to answer it, even if that answer is trivially wrong. Because of all this, it requires immense human vetting to catch these really subtle, highly sophisticated errors.
Which leaves us with this final kind of profound thought to wrap up this explainer. Aletheia proves that AI can increasingly do the heavy lifting in discovering and calculating mathematical proofs. But authorship of a scientific paper implies accountability for its contents, ensuring the citations are fair, the logic is absolutely sound, and the exposition is honest. An AI cannot bear that burden. Even as these tools reach totally unprecedented heights, only a human mathematician can truly take responsibility for the truth. Thanks so much for joining me today, and keep questioning the data.